Good morning, good afternoon, good evening, everybody, wherever you are from. Welcome to Space Spectra number 3. What is the business searching for life in the outer space? I am really glad for the panel that we have today. And I can't really wait to ask questions to this amazing exponents, representative of the space industry today. So first, I'd like to thank you for joining us, and I'd like to explain what it is Space Spectra concept. So as you can see, we all pretty much have a black background with a rainbow spectrum. So Space Spectra is a series of SciComm, let's say, that is born to link especially university students and young professionals to very eclectic and authentic identity that are working within the space industry, so that everybody, irrespective of their education background, could actually feel compelled to come into the space industry, not necessarily coming from a scientific, engineering, or astronautic background, as many of us here are coming from different backgrounds as well. So the spectra is exactly because of the spectrum. There is a huge spectrum of identities, contributions, and roles that we can all take part into the space industry. And today is just a part of astrobiology, business, and marketing, which is an extremely fascinating one to bring all together. So I'm going to introduce you quickly to our panel. I'm starting with, from now is my left, Stella Guillen. She's a VP of Sales and Marketing at Arianespace, and she's been doing amazing stuff for the past decades and one of the leaders of the space industry. And she will be here today sharing with us a perspective from exactly a more business and opportunities of any kind of future projects that we could possibly market and sell in space. Then we have Graham Lau. Dr. Graham Lau is the cosmobiologist. I just love that definition. He's an astrobiologist, a communicator of science, and everything groovy. I just love that one-liner that you shared with us, and we're going to go deeper into that information. And he's now working at Marble Science Institution. Then we have Charity Phillips-Lander. She is also an astrobiologist and searching for life on Earth and beyond. And she's now a senior research astrobiologist at Southwest Research Institute. And to finish this up, we have Richard French. Richard French is Director of Business Development and Strategy for the Space System Divisions at Rocket Lab, which I'm so happy for him to be here, because when we talk about Venus and then we talk about Rocket Lab, they are extremely related from a very engineering point of view. So I'm very delighted to have you here. This is our fantastic panel, and today, how I like to start this with a very first question. So we'll have a first hour where we will have the panel, and then in the last 30 minutes, you all will have time to ask your questions, even come live and ask your questions to our panelists. So hang on until we get to the last part of the Q&A session. So my very first question now is starting with Charity, and it is about probably a very personal story. So what actually did bring you to contribute or start contributing to the space industry in the first place?
So I decided to be a scientist when I was about 9. I realized that it would give me an opportunity to play outside for a living, which I was very interested in, and would provide me a means to escape poverty, which was something that was really weighing on me. My family does not come from money. We're pretty poor. And so when I got to college, I actually found that I really loved microbiology and I really loved geology. And I was like, how do I combine these things? And I sort of figured it out along the way. Astrobiology wasn't really a known field at that point. So when I went to get my PhD, I went and looked at biogeochemistry, so combining biology, geology, and chemistry to understand how life affects Earth's environments. And while I was doing that, I realized it was applicable to searching for life elsewhere. And I decided to make the leap into astrobiology.
Well, that's an amazing story, and to be honest, it's pretty much relatable to what I used to say. I did start studying engineering because I was coming from a very unprivileged, poor background. So it is a bit of well, we totally demystify the fact that to start studying science or engineering, you are coming from an elitist background, because it hasn't been for me, it hasn't been for you. So it's a very beautiful message to say to everybody, just don't be scared from where you're coming from. Actually, you can change it all, as we all have done. And moving on then on the actual theme of the topic of today. So as an astrobiologist and inspired by life on Earth and beyond, so what do you think, where do you think the research and the entire scientific community is actually moving towards to, especially in light of the latest discovery of the phosphine on the Venusian clouds, which wowed everybody? Where do you see we are actually going with that?
So I see astrobiology as growing as a field, particularly over the next decade. I think one of the things that we've seen is that more and more astrobiology focused missions have entered the development pipeline, and we're seeing more astrobiology focused instrumentation that's reaching maturity. And then you're right, we're seeing all of these amazing biosignature type indicators that are indicating that many of the worlds, even in our solar system, are habitable and that they may have the potential for life. And so that's a major driver of business, but also of scientific curiosity and discovery. So I see this as a real net positive time to be exploring and searching for life elsewhere.
And searching for life elsewhere, because again, the space industry seems to just gather, well, or at least the visibility that we have of people that work in the space industry is, again, rocket scientists, engineers, astronauts. So how do you think that the opportunities for anybody like you, for example, coming from a biological background, will open up for next projects? And what kind of also education or skills or extra inspiration our students, our young professionals need to understand that you can be a biologist and still work in space?
So I think astrobiology is coming into itself right now and growing as a field. And one of the best things about the astrobiology community that I love more than anything else about it is that you can have almost any background and contribute to astrobiology, because life detection is such a high barrier to get over. We require so much evidence to claim proof of life that you need engineers and you need technology people. You need people who can develop autonomous sampling and robotics. You need scientists, but you need physicists and biologists and chemists and geologists, because they all understand the system and the questions slightly differently. And so when you look at the astrobiology community, that's what you see, are this really broad range of experience.
Thank you very much, Harity. And you just opening up then to follow this with Richard, because talking about engineering and way of discovering or proving that anything else is alive in the universe, we definitely need instrumentation. So Richard, I will ask you again, like I've done with Charity, the first really question, then we will move on the more technical bit of, you know, what you do for Rocket Lab and what Rocket Lab does for this whole topic, which is extremely cool. How did you even start with the space industry yourself?
Yeah, I think like Charity, and I feel like this is true across our industry, a lot of us are just kind of born into it. You know, from the earliest sort of conscious moments, we're passionate about this, even if we don't really know what it means yet. And so, you know, from a pretty young age, I was trying to understand what was happening in space and getting interested. I remember I think it was, did Cassini launch in '94? I just remember like following the launch campaign and pasting newspaper clippings on the wall of my bedroom, and, you know, remembering the controversy surrounding the RTGs. And I mean, you know, it was just, and then to think now where we are with Cassini having, you know, completed its mission and all the amazing science that has occurred. So yeah, I don't remember a time when I wasn't into it. And I started with high-powered rockets in middle school, and then graduated to satellites in college, and then had the opportunity to go to Jet Propulsion Laboratory. I had a hiring manager ask me how would I like to help land spacecraft on other planets, and that was a pretty obvious answer. And so got to do that for a while. But I'd always been passionate about industry, government collaborations. And so, you know, coming from JPL, where we really focused on first of a kind, one of a kind spacecraft, typically quite large programs, the pace at which we were implementing these missions was a little bit frustrating, and I saw potential with industry to help change that. And so shifted gears a little bit. I joked that I used to have a real job, you know, building stuff as an engineer, but had the chance to go to NASA headquarters and stand up some commercial space partnership programs, came back to JPL, did some of the same, and then finally decided to come into the private sector. And so we can talk a little bit more about what Rocket Lab is doing, particularly with Venus. But yeah, that's kind of the short story of how I got here. Mm-hmm.
Yeah, that's a great story. Again, it's something I can totally relate, you know, especially with rockets and space systems. So I could talk forever about this, but that's probably another kind of conversation. And speaking of Rocket Lab, indeed, it's extremely interesting, the projects that you are doing, guys, especially in the frame of this topic specifically. You know, when as soon as the Venus news were out there, all Rocket Lab articles were out there as well. So it was amazing to see how the pieces of the puzzle are coming together, and actually to see what kind of, you know, in the light again of these discoveries, and surely new ones that will happen, how from a system engineering, from a more technical project, let's say, background, what are the opportunities that are opening up there? What kind of, you know, do you think also there will be more budgets to this kind of missions? Because that's also the usual problem, research and development budget allocated to teams and even students or PhDs that can actually work on this kind of amazing projects. How do you see now this shaking up?
Yeah, a lot of good questions there. You know, we're really optimistic. I mean, to answer your last question first, I do expect there to be growing budgets, both from traditional players like NASA, you know, increasing the regularity and continuing to improve the programmatics of programs like the Simplex program, which is the smallest complete planetary mission line that the Science Mission Directorate has. You know, international space agencies, you know, we just saw the announcement from, you know, come out of UAE for a rover lander. So that it's very exciting to see other space agencies get into the mix. Of course, Rocket Lab has strong New Zealand connections, and we're seeing the New Zealand Space Agency grow. And so there's a lot of really great signs that the traditional space agencies and new space agencies are expanding here. We also see opportunities with non-traditionals, with high net worth individuals, with universities and other organizations that feel passionate about this. And so it's going to be a really interesting financing landscape moving forward. But none of that will matter if we can't bring the engineering systems to bear. And so Rocket Lab is really excited to have solved the small launch problem. We have a very successful launch vehicle, and we've developed a mission concept that leverages that vehicle to do planetary missions. And so the table stakes, it's not $1 billion, it's not hundreds of millions of dollars, it's tens of millions that are required to field these systems now. And so we're demonstrating those capabilities for NASA with a mission to the moon next year. And it was that investment that we wanted to leverage and make a commitment as a company to flying to Venus in 2023. And so it was really serendipitous that we were developing this plan at the same time that the phosphine team was developing their analysis and planning to publish. And so just amazing, planetary alignment, no pun intended, that our engineering investments, our CEO's commitment to Venus itself, and then, the opportunity to catch the home and transfer window in 2023 is all lining up really well.
That's it's a great journey, and we're all very excited to see that happen. And talking about excitement, also there is, of course, the other side of this coin. So again, talking about job opportunities and skills and talents. So these challenges that, in very different ways, we all have to face, experience, and solve from a biology point of view, from an engineering point of view, from a business point of view. They, of course, require now more and more people to get into the industry. So it's funny that, in a way, this global crisis has made us all understand how we rely on space technology, like having this Zoom, for example. Without telecommunication spacecraft, this wouldn't happen. That's why we actually need more and more of these in a more sustainable way, which means more job opportunities. However, at the moment, this doesn't seem to be the case. In a sense that not many opportunities are out there. So one of the questions that I get from the students, from the newly graduates as well, and also other young professionals, is that they obviously don't have that 2, 3, 5 years experience because they're just starting. So when you are, for instance, hiring new fresh blood into your team, how do you choose them? What are the values and the talents that you want to see, rather than a paper written, I've done this, and that, although, I've just started, so obviously I don't have 3 years of experience?
Yeah, good question. And I think you've characterized the landscape well. I will say, I think there is a lot of opportunity. It's a very challenging labor market right now. I actually think that the supply side is the bigger problem. We have a lot of open recs, and it's hard to fill them, quite frankly. There's a huge amount of competition, both within the commercial space sector, the broader aerospace sector, and then I think there's a lot of brain drain happening to commercial tech and other sectors that quite frankly can pay a lot better. And so we're up against a lot of challenges. I think you're right that our expectations for hiring are quite high. We don't compromise on quality, and we do prefer experience. And so, advice that I give to almost all students is, first of all, stick around for an advanced degree. It's almost impossible to be competitive in the marketplace these days without one. Another is project work. Like, you have to have hands-on experience, and there's a lot of opportunities at university these days to get involved with CubeSat and, hands-on research. The closer to flight you get, everything from turning screwdrivers, which I think is as equally important as understanding the hardcore physics of and theory behind what we do. But yeah, I think there is we do have internship opportunities, and we are, if there's a best athlete, all-star who, shows a lot of promise, then we'll bring him onto our team, him or her. International is an interesting challenge for us. We are a global company. We have offices in New Zealand, Canada, and in the US. And so we do have some kind of pressure relief valves for non-US people. But nationality is, continues to be a challenge with export control. And we also support national security space. And so, clearances are a conversation. So yeah, I think, we're doing the best we can to try to bring young people in, but we also have really high bars in terms of quality requirements. One last comment that I wanted to make, I really like the word that you use, sustainable. I think that's hugely important. There's a lack of sustainability in the commercial space industry today. There's a lot of visionaries pursuing very ambitious goals like human exploration, and I support it. I'm inspired by it. But we really need companies focusing on the fundamentals of building out the sustainable ecosystem. I strongly believe that's robotic systems, much more than human, although we'll see a lot of cool symbiosis between those two. It's interesting to look at like the investment landscape, where we have lots of investment going into a huge number of competing, launch companies as an example. But, my perspective is underinvestment in key areas like geospatial analytics, which is really the demand signal for new remote sensing systems. And so, I don't know if it's just kind of the wolf pack syndrome in the investment community, but I do wish there was, this is, we don't live in China, we cannot engineer how investment occurs, but it would be nice to see a little bit more kind of macro thought about where money is going.
Yeah, that's actually a good point, which makes me also move to Stella in a way, because it is true. The whole ecosystem, starting from let's say the way we educate students, and when I say educate, it's just not only having a university degree, because at the moment having a university degree is not enough. Especially these days, people are called up, as you just said, having hands-on experience, whatever it is. I had experience in the garage with my father when I was a child. So that kind of made me understand how the things work together. And that is also something, having experiences of, going off and communicate in a way that is also interesting. So it's like the whole system, the whole ecosystem, starting from the education to then where do people invest and what kind of people they choose for, being the face of their brand, if we say. It has a whole lot of things that many students or young professionals don't know, because they're coming from universities where they are just taught, okay, you have to study this, then you get the job there, and this is what you do. But there are so many other things that are lacking. And then you go and pitch your project to an investor, and you have no idea about the business model, and then you've worked for 10 years on something and the business model wasn't there. So there is so much more to everything that needs to be thought about. And this goes actually now to Stella, which, coming again from a major player in the space industry, can certainly probably relate to many of these challenges that we've mentioned. So first of all, Stella, I'd like to know, what is your journey into the space industry? And I'm sure it's a journey that some of our audience could possibly relate to. And then we can move on to the more complex questions about business.
Sure, Bianca. First of all, I have to say thank you so much for doing this. This is a great way to you know, show our passions for space and actually sort of encourage young people to have the same. My background is completely different than everybody else's, I think. Even though I grew up with, you know, Star Wars and Star Trek, my passion or my, you know, inclination to work in space actually came in my early 20s when I had a job interview at Intelsat. I don't know if you guys have been in that old building, but it's here in DC. And when I walked into the lobby of the building, there were these satellites coming out of the ceiling, and I thought, oh my God, this is so cool. I mean, I you know, I really was enamored with the idea. And then I remember they took me to a like a little theater, and they played a video that showed how they came about, and it was through a resolution of the UN, because it was a consortium of governments back then. So the UN had established that any communication coming from the satellite should be provided globally and, you know, and available basically on a non-discriminatory basis. And I thought that is pretty cool. Not only to get everybody together, you know, all these different governments, but to provide communication to the entire world. I thought that was the coolest idea ever. So I was hooked from that moment, and here I am.
That's cool. That's really, really cool. And obviously, you know, your career is impressive, and it's really interesting. And so the way, again, you see these new discoveries, having been now in that part of the industry for decades, how do you, I'm sure you have an idea of what are the trends now. What do you think is going to happen now, given how exponentially we are moving towards technology advancement? How do you see new possibilities, new projects, the new space economy, you know, just coming as a booming factor with what it was the old industry, let's say?
Yeah, it definitely has changed dramatically, right? I'm not a scientist or an engineer. I have a business background. So my views are, you know, very much focused on budgets, right? That people come and they relate every single project to a fixed budget, and the budgets are coming from different ways today. They're, you know, they still come from governments, but they also come, as Richard mentioned, from investments, from private equity. And that has shifted a lot the way we see space in general, right? It used to be very much a government position, and today is a commercial enterprise. And I think besides the whole idea of finding life somewhere else, I think that even if we end up not finding life, I think just the fact of searching for it brings a lot of great benefits to society in general, right? So I think that how do you measure it? How do you measure like challenges, ambition, curiosity? I think the profitability of searching and exploring space comes with advanced knowledge. I think that's what, you know, it's hard to measure in money unless you have a, you know, an enterprise like, for example, those huge constellations that, you know, are trying to provide broadband to the entire world. Okay, that's something measurable, but how do you measure somebody's, you know, curiosity going and exploring if there is life somewhere else? Very hard to do.
Yeah, that is something that I think I've been thinking myself, because as you said, every project needs to have a return of investment. So that's the baseline. And some of the research that we do for curiosity, or we want to do for curiosity, you don't really know what is going to be the return of investment. It may be massive, It may be not, but the measurement of what these people are looking for with their project is really hard to quantify, because you can just come out with a massive quality of information, but maybe that information doesn't make money. So this is really when you are like borderline, we care about research, but then the money wouldn't pay for it. And this is what many students see, especially when they are PhDs or they are just entering the industry. So why would I care about doing this research if at the end of the day it doesn't make any money, or it doesn't give me any money? So this is putting off lots of brilliant minds to just do what they do, excel in a specific field, especially in the space industry. So what advice would you give to these millions of people out there who are questioning really what they are doing every day, although what they are doing is awesome?
You know, I read this a while back from Alexander von Humboldt. It says, the most dangerous worldview is the worldview of those who have not viewed the world. And I think that applies to space as well, right? So I think the best advice I can give to any students is to, first of all, follow their hearts, because money and investment comes with what you discover, what you explore, right? I mean, there's all this advance in technology that we are now, you know, enjoying due to the fact that we went to explore space, right? But I think that there's a lot of field. So every single industry today, every single industry will expand to target space in the future. I mean, think about designers. Designers can now focus on designing spacesuits. You know what I mean? We're talking about fashion in space. You know, chefs providing food for, you know, space travel, photographers, accountants that will have to deal with different ways of, currency exchange and stuff like that. Space law, I think, is going to be a huge area for the new generation to concentrate on. I mean, how are we going to deal with international cooperation? How are we going to deal with, conquering or, settling in another planet? How do we work with all this debris that we are creating, right? How do we deal with, all the communications, market access, etc.? I mean, there's a lot of fields. I think, science and technology is obvious that we need to have advancements on those areas, but I think students should not limit themselves to that. I mean, there's so many other areas that will have an influence on how we explore space and how we do business in space.
Thank you very much, Stella. It is very true. It is very true. And again, it's giving visibility to these amazing models out there that are doing something that isn't just related to engineering. Anytime when I say I'm a rocket scientist, they say, oh, well, that's the only way to be in space. I'm like, no, you could be a science communicator, for example. That's a way of being in space. Tom Cruise has nothing to do with space. He's going to die, it says.
That's a good one.
So there is a whole new, cluster of things, which makes me go to Graham, who is a communicator of science as well, and all things groovy. I want to know that, Tell us about your very unique journey into this all things space.
Yeah. So one, thanks for having me on. My journey started at 5. I was watching a movie that inspired me to become a musician and to want to ask big questions about the universe. And then growing up, I loved Star Wars. I really loved Star Trek: The Next Generation. I loved the speeches that Picard would give. Patrick Stewart's such an amazing actor. And then I started watching Cosmos with Carl Sagan and started reading books about astrobiology. And I realized not only that I wanted to be involved in the science, but that I also wanted to be someone who could give those kinds of speeches, write those kinds of stories and tell those stories from my perspective and try to share with other people in this realm. And so my academic journey took me through degrees in biology and chemistry. I spent a few years studying astrophysics, and then much like Charity, I got into geology in the realm, kind of like biogeochemistry. I did my PhD more in geomicrobiology. I was fortunate to travel to the high Arctic to do some research, but I still, throughout my graduate program, earning my doctorate, I still just loved sharing the experience, sharing the story of the science with other people. And so I realized that was more my calling. My calling was to be someone who's sharing this with other people. And so since graduating with my PhD, I've been working for Blue Marble Space, and it's given me such a wonderful chance to interact with people from around the world, from different nations, to talk about astrobiology, about opportunities in astrobiology, about careers in astrobiology, and ways to be involved in this very large quest to understand the nature of life. And that quest itself very much comes from our human desire to understand ourselves. And so when I say I'm the professor of everything groovy, it's because I could never settle down and become a specialist as much as maybe I should have. I think to be a good astrobiologist, you have to specialize in some skill, but you also want to be a generalist and try to wrap your head around all of the awesomeness that's out there.
Yeah, it's true. It's pretty much, you know, as I was saying before, you were told you have to study something, but then at the end of the day, when you present yourself somewhere, they want to know, you know, how you communicate, how you speak, what have you done, who do you know? That's very important. Networking. So these are all things that are not really explained to people. Some and another good thing again. So first of all, I want to say that. So we've never met properly with any of you, especially with Graham, yet thanks to some crazy networking channels, especially during the isolation, we just came across and crossed our orbits, because at the end, when you get into the space industry, you realize, especially to students that are now starting to building their network, once you get into the space industry and you know one, and that person introduced you to the other one, to the other one, to the other one, there is this major cluster, and then you realize it's pretty much the same people. So it's like a big family out there where you can go and ask for advice, and they will be there, because as much as space is huge out there, the community here is still pretty small. And coming to a community that is still pretty small, and astrobiology is actually quite a niche at the moment. What is your take on the Venusian clouds discovery, and how do you think it's going to affect us in the future as humankind, first of all, as, you know, curiosity-driven people, and as business standpoint?
Yeah, Venus is a beautiful world. And I want to get there. I want to do research on Venus. I often argue that in the very early solar system, if there was another world that most likely had life beyond the Earth, it was probably Venus and not Mars. And don't get me wrong, I love Mars. Mars is awesome, but there's a lot of stuff to research about Venus, and in the modern day to learn about climate and atmospheric chemistry. But we should be very careful in saying that phosphine detection is not a detection of life necessarily. It's a beginning, but the detection itself needs to be confirmed first. So there's some other things going on there. That's what we call a one-line detection in spectroscopy. It was one little dip in the absorption of the radio waves coming off of Venus that has this data in it that is inferred to be phosphine. It could be something else, and some other researchers right now are looking into this and trying to figure out, could it be something else? And we also have Bepi Colombo. It's on a flyby next month past Venus on its way to Mercury. It has one more flyby next year and could potentially get the data to help us figure out if that phosphine's there. So that said, say the phosphine is there, it could be really, really important for us. We've detected phosphine in Jupiter and Saturn. We know it can form without life in other worlds, but here on our planet, it only forms naturally through biological processes. And so far, they don't have a good reason that it could form on Venus. Now, maybe someone will come along, and I've seen some preprint papers already suggesting, for instance, maybe it's volcanism, or maybe we just don't know enough about what's going on in the Venusian atmosphere yet, which gives us more reason to go back. But say the phosphine's there, say we can't figure out a geochemical or photochemical model for its formation, then we really need to get back there and figure out where it's coming from and why it's there. And if we find life in the clouds of Venus, or even broader, if we find life on Mars, in the rocks of Mars, or if we go to Europa with Europa Clipper and we spot some biological signal in the Linnea, these cracks at the surface of Europa coming up from its deep ocean, that finding would be staggering, it would be humbling, and it would propel us into something very new. The discovery that we're not alone in the universe will be a shocking one that will really inspire people to come together, I think, on this planet. I think we had one big jump with space exploration. Once we started going out and looking back at ourselves and seeing our blue marble as one single world and knowing our fragile place in the cosmos, that gave us this knowledge that we are in this together. But if we find life somewhere else out there, that's that next big jump that we need to really come together and make things better for ourselves here.
That's, yeah, it's a beautiful story. It's quite romantic, you know, the whole story about Venus, and it is true. It is true that many times humanity needs external, let's say, external factors so that we understand that we are one. However, on the flip side of this, we all have to know already that we are one, because going to Venus, or going to Mars, going to the moon, going to wherever in the solar system isn't a mission of one person. It's a mission of the entire humanity. So it's a bit like chicken and egg. How do we get ourselves around the fact that we have to together cooperate, from the students to the seniors to the investors to wherever else politicians in the world? We all have to be one on the same side so that we can all advance together to that farther reach of the solar system.
Yeah, I mean, often we lament that we spend so much more on military budgets than we do science budgets. We lament that we're spending most of our time in our politics around the world bickering with each other rather than improving education and improving the lives for everyone, and improving the availability of food and water, and making it easier for all of us to be involved in this mission together. That said, I have a lot of hope right now, and I've been gaining more hope through this pandemic, honestly. It's been rough for a lot of people. We've lost a lot of people. It's been tragic. At the same time, like I said, I've noticed now so many people from around the world getting involved in the conversation, so much so that I wouldn't be surprised in 5 or 10 years from now if we start seeing a lot more astrobiology programs run by other governments. For instance, ISRO in India, they don't have an astrobiology program yet, but given how many people I speak to from India every single week who want to be involved in astrobiology, I wouldn't be surprised if ISRO will start an astrobiology program very soon. I think we'll start seeing more of that around the world. And because we're all connecting online so much more right now, it's also opening up opportunities. There are more online internships, more chances to network and connect around the globe. And so that gives me a lot of hope that a lot of the young people maybe watching right now can be involved right now and can join the conversation with us right now.
It's true. It's true, and that is it is possibly the best thing that could happen during the pandemic. It's awakening the humanity to a new truth. And I saw that everybody was nodding heavily, you know, at the words. So I saw Charity really nodding and smiling. Please, what is your vision, and how do you think we do know that we have to merge on Earth first before we do this amazing visionary stuff in the outer space?
So I think I see this happening organically, a lot of the same way that Graham has mentioned. When we talk about instrument and mission development, there are more and more international partnerships, public-private partnerships. And so what we're seeing are that people who are interested in these big ideas are coming together in the virtual space and as much as we can face to face, given social distancing, to try to move the ball forward on these things. You know, astrobiology can't be pursued by one type of degree program and specialization, and it can't be pursued by one type of person. I think astrobiology is one of those fields where diversity is a forefront issue. We need diversity of ideas, backgrounds, thought processes, because we can't do this. We can't search for life elsewhere if we don't bring everyone to the table.
Yeah, that's still true. It looks like it's still quite difficult, you know, to understand, but this is the only way to go. And before I open now the Q&A session, both the other two guys, Stella and Richard, were nodding at many of the things. So Stella, what is the hope that you have out of this, you know, exponential growth of research, discoveries, and space, you know, relatable needs during, you know, this very crucial time of humanity?
I think it's going to be extremely important just for the sustainability of Earth alone to be able to cooperate and see, actually, I mean, think about the environment alone, you know, I mean, how do we get out of our little bubbles and look at the world as one? I mean, it's through space. So I'm very hopeful that economies will grow through that concept of looking as one. You know, I'm very hopeful that also, you know, as we get more people to see Earth as one. So space tourism, for example, an industry that I think is going to boom soon, is going to be very good for how we perceive humanity in general. And how do we, you know, there's no boundaries, no, you know, no colors, no, you know, different backgrounds. I mean, everybody's going to be looking, hopefully, as one, right? So that's my hope. But I actually have a question. It's been bugging me. It might be a silly question, but how do we define life in space? Or what does it define life in space?
I'm sure that was a great question that was coming from the Q&A, so that's awesome.
Good. I'm not a scientist here, so.
I want to know that too, so please, guys.
So yeah, I'll jump in here for a moment. That question, what is life, is an extremely important question, especially for those of us who want to go find life elsewhere and maybe understand how life started here or came here and then evolved here. The truth is, though, we actually don't have a single definition of life. If you look out in the literature, you'll find a few hundred attempts. You might most commonly see what some people call the NASA definition, that life is a self-contained chemical system capable of undergoing Darwinian evolution. And it's a pretty good definition, but it still misses out on a lot of things. Viruses, for instance, we don't actually know how to fit those into our understanding, our definitions of life. Artificial intelligence, maybe most life in this universe, if there is other life out there, maybe it becomes post-biological. It becomes an artificial intelligence of some form. And maybe that's the most common life out there in the universe. And that doesn't fit into our definition of life. And so the truth is we have a working realm of knowledge in characterizing life that we're using to look for life out there. And I think we're becoming far more sincere with ourselves about the fact that life might be very different from life that we know here. And so we're looking for what some of us call agnostic biosignatures, signs of life that would fit for any other kind of life as well. But yeah, it's a very difficult realm. What is life, and then what is consciousness is even worse. Let's not go there right now.
Thank you. That was perfect.
Charity, what is your definition then?
So I agree with Graham's definition. I guess I sort of view life as being the explanation of last resort, because that's really the benchmark for life detection, is that we cannot explain it through any other known process that exists, because life as we understand it right now exploits processes that would occur naturally. And so that's often one of the challenges with searching for life, is how do you differentiate this? Is it an abiotic process, or is it, something biological? So once you've eliminated all other reasonable or rational explanations, that's when you can get to saying something's life.
And it is interesting because from what, from the explanation itself of life, it looks like this should be applied to all of us when we are having hard time understanding diversity, because it looks like we only have one parameter to understand how humanity express, but still we are just one life known officially, yet we have different expressions. So it looks like, it's a way of just being tolerant to our own beliefs, religions, politics, whatever, before we can actually be tolerant to a new life. And now there are lots of amazing questions coming up, which I'm now going to open up. But before that, from a very engineering point of view, Richard, so having you had experience with interplanetary missions, and now specifically going towards Venus, what do you think is that, the drive from, let's say, an engineering point of view? Because of course we understand what is our own discovery of new life, new consciousness. It goes a lot with a more philosophical way of thinking about life in a way. But for the engineers, from the scientists, what is actually the drive of, contributing to that tiny little piece of the space system to then go and land something onto another planet? Many questions I have. I worked on Mars missions. They are now on Mars. Why do we care? Again, besides life, why do we care?
Yeah, I mean, I think it goes back to a lot of the ideas that we've been discussing here. And I really like the multidisciplinary challenge that astrobiology poses, because it really does bring us all into a common, problem set. So I'm kind of a history nut, and it's interesting. You can't really read a history that's older than about 20 years because there wasn't a multidisciplinary approach in history. There weren't climate studies and other, disciplines being brought in to put history and, historical studies into context. And so that discipline is going through a revolution right now, which is amazing. And so, this astrobiology problem is quite interesting, because the whole reason we go to other planets is to understand Earth better. It's a different laboratory. It's a different set of conditions. And we've gotten a lot of exposure to the science team that made the phosphine discovery, potential detection, in particular with Sarah Sager's team with the Breakthrough Initiative study of Venus that's happening right now. And so it's been amazing to see that group, which is extremely multidisciplinary, and the way that they communicated this discovery as, well, it could be life, or it could be we just don't understand. And so it's like, perfect, there's so many questions that we want to then answer, and most of them require we go. And so we love that. We don't want there to be a single instrument that answers this question. We want there to be 15 missions that have to go and answer this question, so we can do it lots and lots, and evolve science. And so that's very exciting. And it will be interesting to see how, as we make these discoveries, how people get engaged, because it is so complicated. We think about it every day. And, as Graham was saying, as Charity was saying, like these are very philosophical, very complicated issues. And so it would be nice to be able to communicate those and get people's engagement, but it takes a lot of work. And I do worry that we're sort of leaving behind the bulk of humanity here as we sort of pursue these ethereal goals. And so it's super important because we want the programs to be better funded. We want people to be engaged. It should be obvious that Earth, studying Earth is important, and that planetary science has a big connection to it. My mind was blown because I was never, I didn't really understand the connection between exoplanets and astronomy and planetary science. But a couple of years ago, I was listening to this talk on Kepler, and all of a sudden it clicked. It's like, and now like exoplanets and doing astronomy is almost more important than doing in situ measurements. But that's a whole different topic. But so that's another really important aspect of the multidisciplinary nature. And it would be just great if more people understood that so they could engage.
That's true, and it's a great advice. Again, it goes down to visibility, education, communication, which is very, which so far probably, communication about space has been really far from humanity problems. Actually, it's just one of humanity's business, probably one of the most important, because we are all suspended in space. So if we don't care about this, magic bubble we are suspended in, what do we care about? So I will now open the Q&A, and I'll ask our audience to come on and ask the questions live. So we have the first question from Tapaswini Sharma. Would you like to come live and ask this question? It is about life, of course, on other planets. Hi, Tapaswini.
Hello, everyone.
Hi.
It's such a pleasure to be here and listen to all you amazing people talk about astrobiology, which is super amazing for me. And so my question today is, how exciting do you find the new discoveries, like finding buried lakes of water on Mars and now phosphine on Venus? And which place do you think is the best to search for life?
Thank you. Yeah, Graham, you go first.
I'll jump in first. Hi, Tapaswini. You are a rock star, and I love what you're doing. Keep it up. Keep working hard. Tapaswini is a young woman from India who's been working very hard to get involved in research and to learn more. I've seen her a bunch, and she's one of the examples that I give of someone who's using this space to connect. So hello. To answer your question, it's very exciting. There's so much more for us to know. I mean, in the past 10,000 years, we humans have gone from a very tribal kind of existence to becoming what we have now, but there's still so much more for us to explore together, for us to learn out there. And being involved in that process is humbling and beautiful and inspiring. And so I'm glad that all of us can take part in this journey together as we learn more about our place in the universe. But to answer your question a little more specifically, if I had to pick a favorite world in our solar system, like I said, I do love Venus, and I wish we could get there with some more spacecraft. There might actually be some ancient rock on Venus. The surface of Venus seems to have melted out quite some time ago, but we don't know if there could be some remnant ancient rock for us to look at. And as a geologist, I find that exciting, but I really love Europa. I really want to know if ocean worlds in the universe can have life. And if so, maybe life on planets like Earth isn't the most common form of life, because there's definitely going to be more icy worlds out there. So that inspires me a lot to want to know more and to get out to Europa and start exploring.
Thank you, Graham. Charity.
I mean, I think broadly, there are going to be a lot of great places to search for life in our solar system within the next decade. And while I'm a strong Mars enthusiast, I have to say, actually, the place I most want to search for life is Enceladus. And I'm going to admit, full disclosure, I'm heavily biased on this topic. But I think the fact that the ocean is being spewed into space and we can sample it, and that Cassini has already demonstrated that there are organics and that Enceladus is a habitable world, is a very compelling case. And there are a number of mission concepts that are in development to address whether or not Enceladus has or had life. So I think that would be my bet.
Thank you, Charity. Richard wants to add something.
Well, yeah, I mean, when we can't miss an opportunity to say what our favorite place in the solar system is to explore for life. I mean, this was like a constant debate at JPL, and there were, you know, there was the Enceladus camp, and the office that I was working in was investing heavily in ocean worlds technology. We were leading development of a probe to melt through the ice sheet and to get to the ocean below, which is, you know, just fundamentally important that we have a program that can actually access the ocean. You know, notwithstanding the fact that there are some great opportunities to sample plumes and things like that. And you know, the discoveries on Pluto, even, like, who would have ever imagined that Pluto could seem alive? I mean, it's just like our understanding of the solar system seems to be so primitive that the potential targets for life just grow every day. And so one that I particularly like, I was at AGU last fall, and there was this great talk about quantifying the amount of ejecta, which is basically being exchanged between planetary bodies, and as a potential, you know, mechanism for propagating life. And I was shocked at the volume or the mass that was being estimated. And so I really like small bodies. I think, you know, we need a lot more in situ measurement of small bodies. I think that's a really important part of the program.
Amazing. Thank you for the answers, and thank you, Tapaswini, for being here and for your question. And yeah, as Graham said, you are a rock star, so we all know you, and I'm so happy to see you all the time at, you know, at our WebEx and any kind of event you are there. So keep going. Thank you. And we have other great questions. So Samista has multiple amazing questions. Some of them I've been thinking about them a lot. Samista, would you like to come on live and ask your questions? No? Then I'll ask the questions. So the first one is, exploring space and finding new life forms is exciting, but we have learned painful lessons from humanity's history. How do we prevent history from repeating itself? Humanity from colonizing other life forms and their homeworlds, which is an amazing question. Who wants to take that one? Stella.
You know, I don't have a favorite place per se, but I get very excited about the idea of just space travel. And I think one of the ways of looking at history and, you know, and past performances is to really concentrate on what will get us. I mean, you know what I think about? I think about traveling in general. I think about, okay, before going to a place, you know, I look at all the pictures, right? Before visiting a new place, I look at all the sites that I want to go to, that I read about them. I make sure that when I get there, I go to, you know, several points that I know for sure that's what I want to see. And I think just doing that, it requires for us to get going on transportation, to concentrate on how to actually, I mean, I agree with Richard, robotics is going to be obviously huge and we have to do that, but we also need to be there. We also need to get humans out there. So I think that concentrating on transportation to be able to, you know, I don't know, see it by ourselves and perhaps discover. We have to go through the pain, just like we did when, you know, we discovered America. I mean, it's the same thing, right? I think we have to go through some pain, and I think there are ways of reducing the pain. I think in also taking care of different disciplines or knowing about disciplines is very important, because then you have a broader view of things. Does that make sense?
Yeah, it does. We know that the word, let's say, anytime we talk about interplanetary missions, the word colonization is more used than settlement, which probably would be the best suited. And I see Richard as unmuted. So what is your take on this one?
Yeah, a couple of quick sides of the coin. I mean, in a traditional, sense, we talk about planetary protection, and there's very well developed procedures and requirements for trying to eliminate the biological contamination of planetary environments. They do tend to be quite costly and cumbersome to implement, but Rocket Lab is committed to following those rules and working through the regulatory process to both streamline the implementations while meeting that ideal. But it is a very fascinating question to think about even a robotic mission as colonizing. There are, Jeff Bezos and the Elon Musk of the world and others, Bob Zubrin, who inspired me with his books when I was young, who are very pro-colonization, and I'm certainly one of them. It's a romantic notion, but it's obviously one that is fraught with historical tragedy and really bad connotations. So I think it's a very reasonable question for us to think about. Probably in the short term, the contamination of the lunar environment, which is a very sensitive environment, and was inextricably changed when we went the first time, and will be even more so with the level of impact that's been imagined for this return to the moon. But there's a point at which human progress will likely trump the microbes' rights. Yeah, so we also have to potentially face that we will not be adhering to the prime directive.
Thank you, Richard. Charity, Graham, would you like to add anything to this? A very broad and complex topic.
Yeah, I'll say that through the lens of history, we know that we've done some terrible things ourselves. These ideas of colonization, of how we've mistreated other humans when we've moved into new lands. And we've also learned about the destructive processes, the things that we've done to the environment, to other species, overhunting whales, destroying the dodo, many other species we've impacted. And it has to be argued that we're still doing this today. There are still people being mistreated around the world by other people. We are still destroying species left and right through our activities. And some will even argue that we're driving a mass extinction right now through our activities. And so we have to be mindful and thoughtful about the fact that this is still happening right now. That said, because of that lens of history and our awareness of this process, these things that we're doing now, I think it helps us to be more mindful when we go out to explore. And if we send humans to settle Mars, or we send our robots to go explore other worlds, I think we're being more mindful now than ever before about the importance of protecting other potential species, other organisms that could be out there, as well as those environments themselves. And some have even argued that for Mars, for instance, maybe we should set aside some parks or wilderness preserves of Mars where humans and robots won't go to preserve parts of Mars for future generations, or for potential Martians who could live there right now, for all we know. But I think we also can't stop ourselves from exploring. Well, we are curious creatures, and we've always been curious creatures, and will continue being curious creatures. And it's a human need, an inherent drive to go out and explore and learn more and to go do those things. And so we're going to do it. The important thing along the way is to make sure that we are being just and honorable for ourselves and for other potential life out there.
Thank you, Graham. Charity.
So I see this as an ethical question we struggle with all the time within the scientific community. I agree that we are working really hard on planetary protection to minimize our impact on the planetary bodies that we are studying right now. And we're getting better at planetary protection through time. There is going to come a point probably where we are going to have significant impact on another world. We've seen our impact on the moon already. We're going to see more of an impact with commercial and private partnerships, with more missions going to the moon, and we're going to learn a lot from that process. But I think this is actually a great space for people who are in humanities and law to contribute to this conversation and discussion, and really help the scientific community drive ethical exploration so that we're not setting up a situation where we're repeating the mistakes of the past, where we're minimizing the impact or the cost in terms of ethical cost and impact these other worlds and the potential life that might exist there while we're exploring. And so I see this as a place of fusion for the humanities and science.
Thank you. Thank you very much for your answers. And I'll move on now to a couple of other amazing questions coming from Diana. Diana, would you like to come live? Hello.
Hello, can you hear me?
Hi, yes, we can.
Okay, perfect. I have two questions. The first one. Oh, wait, I forgot it. Okay, about, I can't remember who mentioned about when you're trying to get a place in an internship or in a job interview or something. You talk about experience, but I essentially think that that's not, oh, it is important, but when you have two candidates with the same experience, what will you take in count to actually choose? Because, I mean, if they studied in the same place, they did an internship in the same place, they have been studying the same for 3 years, how can you choose one of them? But it's important to recognize in that place. Yeah, that's the first one.
Thank you, Diana. And I must say that he connects pretty much well with another question that is coming later from Ton Timako. And probably we can join both of them together because, so the question is, the biggest challenges in the industry that you think students should focus on from the very early stages. So how do we wrap this all up? Stella.
So one of the things I look into when interviewing people that have the same background and same experience is let's not confuse experience that is intellectual experience than life experience. Life experience is very important, and when I say life experience is how you see the world, how did you learn about the world, how did you learn about your love and your passion for space. And I also look for enthusiasm, because a lot of people that choose to go to school and do a technical career, they focus so much on getting the problem solved that they forget life in general, and so the enthusiasm is limited. And so it's important that when you interview and if you feel strong that your capabilities and your experience are enough for the job that you're applying, that you show something outside that, because seeing personality through a resume or a piece of paper, or enthusiasm or passion, it's hard to do for whoever is interviewing you. And it's important to do the balance. So if you are a lover of life, go hike, go, biking, go, travel, go, and those are experiences that, yes, you can see in your resume, but it comes out during the interview process. So I hope that helps.
Thank you, Stella. Who else wants to add to this question?
Yeah, I'll add some thoughts. I mean, I would hope that if both candidates are sort of meeting the threshold for our quality, and then we would just hire both of them. So that we would want to be able to do that. But I agree with everything Stella said. There's an interesting. Well, I guess I'll answer it first. Having kind of demonstrating an ambition for learning and for reaching across interfaces to try to understand what's on the other side, and kind of not being contained within your swim lane, I think is very important. And that can express itself in terms of how you seek responsibility, how you've grown yourself, how you've added skills. I mean, there's a lot of ways that can express itself. But one thing that I sort of would warn is the other side of that coin is, we do need people to get the work done. And I do feel like particularly, and I don't want to generalize about millennials, but I do feel like there's kind of a trend these days for everyone to be wanting to be in the spotlight, wanting to post the video, wanting to, and maybe skipping this very important step of like actually doing the work. And so, we love people that we can put on camera. We love people that we can put in front of our customers, engineers who want to grow and add skills, but like we do need engineers to do the thermal design and write the software and make sure the power system isn't going to fail in a radiation environment. So yeah, it's an interesting balancing act. That yeah, yeah, if you can somehow have both of those worlds, like have ambition, but also be dedicated to getting our projects completed, then yeah, you've got a great future with us.
Thank you. And Diana had another question on the sustainability side of space. Which one was that, Diana?
Yeah, Ms. Cefalo mentioned something about sustainability when you're talking about space, and it really comes from my mind that we have a huge problem with the space debris, the space pollution, and it's something really important that no one is talking about. So do you think that we should actually focus on our current problem with space debris before going forward to space exploration and colonizing Mars or Venus or any other planet?
Thank you. Who would like to answer?
I'll start. I think, so you might not have heard a lot about this, but there actually are people out there who are actively studying space debris. And there are people who are pointing out it's problematic, that we're putting more and more stuff into low Earth orbit and medium Earth orbit, and eventually it's going to start getting a little clogged up. For instance, we have Starlink going up. We are putting not only hundreds and hundreds of more satellites in orbit, we are putting tens of thousands of more pieces of material into orbit. And people are actively trying to track all the materials, but we do have this issue that there is debris up there. And we also have this military issue that several nations have now shown, including the US, including India and Russia, that we can blow up satellites using missiles. We can target each other's communications networks and things like that. And that's problematic because if it comes to war and we start destroying all these satellites, then we end up with a very large field of uncontrolled debris. And so there are a lot of us who are not only interested in it, there are people working on it and trying to figure out how to fix it. There are proposals for various missions that will go up and clean up some of these old satellite materials that I think are very cool. But you're right, it's really important, and we do have to have that conversation openly.
Thank you, Graham.
Yeah, I'll echo everything that Graham just said. Excellent points. As a satellite operator, as a launch vehicle operator, and as a company that's developing a lot of plans for use of space, we understand the problem. It's important for anybody who's operating in the space environment to be quite sophisticated in this, to be able to manage the flight dynamic systems, to be able to know where you are, where you're going, and what's coming at you. And one of the capabilities that we have in space propulsion is key to then being able to act. So that's there's a regulatory regime which needs to mature, both in terms of the requirements to deorbit and how you safely do end of mission. But there's also a very exciting commercial ecosystem growing up. Companies that track objects and sell data, companies that offer capabilities that can help solve the problem, whether it's deorbit or on-orbit maneuvering. And companies like Rocket Lab will advocate for not only a regulatory regime that requires us to act in the right way, but also to have the products to have it close in an economic way. The 60,000 or 60 million or $600 billion question is whether we can really clean up the environment, and whether that can be done in an economical way, ideally one that actually drives commerce and helps support that sustainable build out of the commercial space economy. I would love to see that happen. It seems like now governments are really going to have to lead in that investment. Thank
you, Richard. Charity.
So I'm going to take a slightly different tack on this question. While space debris is one environmental challenge that we face, we have a number of environmental challenges, air pollution, water pollution, things like that. And so what I would argue is, rather than postponing space exploration in favor of solely trying to solve those problems, these problems can be solved in tandem. I worked as an environmental geologist for several years before I went and got my PhD. And we used microbes a lot to clean up oil pollution and metal pollution in the environment. And the things that I learned from those jobs are applicable to searching for life elsewhere and understanding microbial processes. And so I think we have a potential for synergy here between astrobiology research and Earth-based solutions. And so I think if we pursue these objectives in tandem, we can help drive creating a cleaner world for ourselves while also driving space exploration.
Thank you. Thank you very much. And I'll pass now. Thank you, Diana, for your questions. Very, very relevant questions. And now there is one question coming from Mark. And that question is specifically to Graham. Mark, would you come on? Hello.
Did we lose him?
Yeah, well, probably there is some connection issues, but I will start reading the question and then he'll probably get the connection working. So Mark is asking, is stating, I have worked extensively in multidisciplinary geospatial analysis, information dissemination, and pedagogical applications. I would like to become a part of this research. How would I make contact and determine if my abilities are usable at present or in the future?
Yeah, so one, that's a wonderful background to begin with. The key thing is, what kinds of questions does he have that he can be involved in the search for life or in our research? And those questions will then be the guiding force for who he should reach out to, who he should ask, if there are openings in laboratories, if there are positions in various companies or government agencies or institutions. So that's the important part, is knowing where you want to work, because astrobiology is a very broad realm. There are lots of us in astrobiology coming from different backgrounds. And so if he wants to be involved in like bioinformatics and understanding which organisms thrive in certain ecosystems, that's an entirely different realm than someone who's doing research on the atmospheres of exoplanets. We're all still astrobiologists, and we're all still part of this larger realm of trying to learn more about life. But there are very specific areas where he could be working. And so I think my first principal advice would be to figure out what inspires you the most. And this is for everyone. What questions do you actually want to be involved in finding the answers to? That will then help guide you to the people who are already working in that realm. And if you have some really cool idea, maybe there's no one working in that realm and you'll be the first. And if that's the case, though, you still will need people who can help you and support you and kind of work in similar disciplines. And they'll be the people to reach out to. They'll know where you can apply for certain positions and jobs. And so my advice is always to find the right people to connect with who can help you then find out how to answer your questions.
Thank you very much, Graham. And so we're moving towards the last 5 minutes of this panel. So I'll have just one more question and then we'll wrap this up. So one question is coming from Samir, and this is more technical based one. So Samir, do you want to, yeah, you're on, please. We can't hear you yet. I'll ask the questions in the meantime. So what technology breakthroughs do you see as the most important that we need to develop to better understand where else in space life might exist, or how abundant it might be? So yeah, from a purely technological way, what are the moonshots we should be looking at?
Well, I'll selfishly answer and just say, we should be firing off missions, multiple times a year to a variety of destinations. I mean, there's nothing like sample size to drive science in the right direction. I mean, that's part of the reason why exoplanet studies are so exciting, because you can survey lots of different planetary environments. Unfortunately, you're limited in the diagnostics. And so, pairing larger sample sizes of in situ measurements. I think the instrument tech is sort of there. I mean, there's always going to be a new instrument, a holographic microscope, a better spectrometer that can determine chirality of proteins, or the next question to answer. But to me, it's really about the platform capabilities to enable a higher rate of science return.
Thank you, Richard. Stella.
I would say also making propellants available in space so we can, help with the transportation, extraction of metals, different ways of doing mining so that we can build things in space. This 3D printing, for example, in space, things like this would help with the whole energy and transportation piece of the industry.
Thank you, Stella. Any adding, Charity?
So I'm going to add to the in situ resource utilization and multiple launch opportunities and say one of the things we need is to continue developing autonomy for these robotics, because and the Europa-Lander is a perfect example. That mission would have a very short lifetime. It wouldn't have the opportunity to have people on Earth telling it what to do all the time. And so it needs to select the samples and process the data and prioritize downlinking that data all autonomously. And so that's a huge area of development. And in addition to that, I think big data is coming for planetary science.
Thank you, Charity. Graham?
I was actually going to say the exact same thing. My two big things I'm excited for are automation and next generation space telescopes. Charity's entirely right. Not only in automating the process of collecting the data, we need very good instruments that can collect great data, but teaching our robots on board to analyze the samples and figure out which data are the most important for sending back to us, since the downlink is very limited. And then yes, big data, collecting so much data, we need automated systems, machine learning systems that can figure out how to give us the right data we need out of this humongous data set. And then, like I said, my other thing is next generation space telescopes too. We are only just beginning to understand about exoplanets. I mean, for all of us on this call, when we were born, we didn't know of any exoplanets out there. We had no confirmed detections. And now it's over 4,000 confirmed exoplanets. And I have a feeling in the coming decades, that number is going to grow staggeringly. It'll grow to tens of thousands and then very quickly start to rise past that. That leaves a lot of potential for us to discover life out there. And we need better telescopes. We need bigger telescopes that can collect more light and can collect more data, and then even having some autonomy there in really processing that data and getting us the right results. I think if there is life out there to be found, I'm very excited for what we're going to find in the next decade or 2 or 3 with this next generation of space telescopes. It's really exciting right now.
Thank you so much, Samir, for the question and the panelists for the answers. But now we are exactly on the dot. It's 5:30 here in London. And I want to thank you, everybody, for joining us today. The panelists and your awesome insights. It's been an honor having you here. And I would go on with my personal questions forever, but I'm very conscious that we all have a life outside this webinar. So thank you very much again for joining us today. To everybody, thank you, Adele, for coming here and helping us, especially when you are not feeling that well. Thank you, everybody, for showing up. Thank you for joining Space Spectra number 3, and I'll see you next time. Bye.
Thank you, Bianca.
Thank you.
Thank you, everybody.
Everyone.